As an example, you could have 1 plus t, 2 plus 5t, negative 1 plus 6t. This came from some example in your book. It's the parametric equation of a line. Because if I could rewrite this just to remind you, and nothing else, this is really R0 plus, I forgot what they call the letters, T times V. Yeah, that one. So in this case, your R0 would be 1, 2, negative 1, what you were just asking, Major Colgan. And your V would be 1, 5, 6. And that is really, if I multiply all this together, I get back to where I was. So this is a line, but it's a line in space. That's the lesson I did with you guys. Don't fall asleep on me yet. I'm tired. If you fall asleep, then I'm gone too. Teacher's sleeping. She's already standing up. What do we do now? Okay, so what does that look like? If I plot it just the way you did on the board, if I made some points and plotted it, I can do this. How do you guys feel about Mathematica? Not use it. It is cool. So right around the time that I went, so we have these things, you can never go to them because they're all summer long, but they're called research experiences for undergrad. They started it around when I was in undergrad. I was not of drinking age yet, and I got to go all summer to Pearl Street in Boulder, Colorado, and spend the summer there. And that's where I saw Mathematica for the first time. And it did algebra for me. And that was, wow, something that does algebra for me, I think I might go get my PhD. I have a chance now. So it actually leaves a lot of things easy. And over the years, I developed a friendship with Stephen Wolfram. And so we talk a lot about how he started this and why he did this. But look how amazing it is. You can draw these things. Some of what you're learning is obsolete. You can just do this with you can do this with your cell phone now. But I did it at Mathematica because it's an expensive tool and it looks a lot better. This one, let's do one more. And by the way, for the code, I just actually just go into ChatGPT and say, give me the code to write it. And I don't do it myself anymore. I used to use the help browser and kind of figure it out, but you can just say, give me Mathematica code to make this graph in 3 dimensions with arrows. And that'll give you the code, you copy it, put it in a Mathematica, shift enter, and you can see the picture. All right, so let's do one more that's more cool looking because lines look kind of boring. Any questions so far? So what could you possibly get on a WPR? I'm just giving you different ways to represent this. This is another way to represent it. This is the way physics represents them. I, J, and K are what we call basis vectors, and the coefficients are really what are important. So that's why we write it this way, because you want to store less information. The cosine t, sine t are the x and the y, and the z is t. So how do you, if you don't have Mathematica, which you won't, I don't think you'll have Mathematica on the WPR, I would give it to you. If you want to learn it and use it, it's a tool, you should use it. All right, but let's go. Without Mathematica, how do you plot this? Okay, first of all, what you do, step one, separate out the component. For a cookbook problem from the for a test, you're going to get something that you've seen before. Step two, start on the floor. Plot this thing on the floor. Floor is the XY plane. So I have this. Whoops, that's not a line. So I have the x, this is z up going straight out, and then out b is x, this is y. What's it going to look like on the floor? This, if I just ignore z and pretend it didn't exist, on ground floor, what does x equals cosine t and y cosine t make? Makes a circle, right? So recognize that on the floor, I'm going to get a circle. This is my circle on the floor. It's the unit circle. It's on the floor. Now, as you go up to the floors, like step 2 is to think about what happens to that shape. This is how I explain it. I don't know how better to explain it, but z is t. That's the z component. So you're taking that circle, and as you go up the floors, it's the z component's going up the floor and taking that circle with it. So it's like you have the circle on the ground floor, you pick up part of it, and you start pulling it up. As t goes up higher and higher, you go up the elevator with this circle. You take the circle with you, and it's going to spiral as you go up. It's like you took a string off the floor, and then you're going to go up. You're just going to push the elevator button, and it's going to take you up, and you're pulling that circle with you as you go up. So take a string, start pulling. It's going to do this. It's like you took it with you on the elevator, but you're making circles as you're going up.
It's like weighing the slinky down flat.
That's exactly how I thought of it, but I thought that you guys were too young to know what a slinky is. Right? I already just told you that I met the guy who discovered that we can't predict the weather. Yes, you can think of it. It is like a slinky. So let's see if Mathematica is right. Boom. Mathematica got the same thing I got. So Mathematica is right. There it is. So a slinky is a cylinder, right? So if it didn't move, it just would be a tin can. But since t is increasing as t goes up, y equals or z equals t, it's being pulled up. Oh, and there should be arrows, right? Because there's a direction. One more, I'll send you to boards and you try something out. Right? Is this making sense? Not making sense? Good. Does everybody know how to do this now? Find the vector equation of a line? This is for WPR. This is WPR review. You want to do monkey see, monkey do?
Yes.
All right, monkeys, let's go. I don't know because I haven't been going to PD meetings, but I can find out and text you guys. If you do, you have to think exactly like this. Start on the floor with X, Y, and then pull. For you to be able to do it in WPR, it's got to be something that you immediately can see on the XY plane. Like I could immediately see that's a circle, right? So yeah, they're not going to say draw the Lorentz butterfly. They're not going to ask you to do that. It's going to be something very like clear.
At what point do you know like where to start? Like when you're drawing from the floor up, like where do you start on the circle?
I always start on the floor. Or you mean, where do you start pulling? If you,
Any angle in the circle, where do you pick up? Well, you have to start at like
yeah, you have to start at t equals 0. So it's going to spiral there anyways. Yeah. I mean, you have to think strategically also of grading. How would you grade? You know, you're probably going to get like a T-Rex drawn by somebody. How do you grade that? So that would be really hard to grade. But somebody could ask you something very simple. Like they could ask you, how would you plot y equals x squared plus y, how would you plot x squared plus y squared equals 1 in 3 dimensions? What does that make? That one is a no-brainer. That one I could ask. I would ask that. How do you do x squared plus y squared is equal to 1 in 3 dimensions? We'll think about that after this one. Let me do this one quickly. What is it? It's a circle on the floor. Yeah. But to bring it up, it doesn't have, like, for every z, it's the same circle. It's not a different circle for every z. So you stack a bunch of circles up, what do you get? Cylinder. It's just like if you have y equals 1, there's no x. That means for every x, y equals 1. For every z, it's the same circle. Same idea. 2 dimensions through 3. Okay, so I did this before with you. So step 1, find direction vector. Oh, yeah, thank you. How do I do that? Yep. You do tail to head, and I guess I didn't do the math. 2 minus 1 is 1, minus 1 minus 3 is minus 4, 3 minus the minus 2 is 5. That's my direction vector. Step 2, let's skip the old step 2 and just go plug everything into the formula. Plug into R0 plus T times V. So R0 could be any one of these points. I'm just going to pick P. 100% you will get this tomorrow. Guarantee you. They might even do something easier, thinking, oh, we'll make it easy on them. We'll just give them, here's a direction vector and here's a line that goes through this point. Find the equation of the line. And that's even easier. That's even easier because then you don't have to do any tail to head business. What? Go ahead. Did I make this arithmetic mistake? I could have. I'm going to hide it and then fix it and then open it back up and say that, oh, yeah, I don't know where you. Yeah, all right, we'll do that. Okay, so let's try number 3. Give number 3 a shot. Take forward, try it out.